on sum and difference formulas, and you can find all your sum and difference formulas on your reference sheet. So these are what we're going to be working with today. Now, they range in how you guys are asked about these, so there's a lot of different types, and part of this stuff you guys already know how to do. Our little star problem, if they gave you guys something about cosine being 5 over 13, and they say it's a positive acute angle, but you want to find the sine. Does anybody remember which one to draw? Triangle. Good job. All right. Now, if they said something about positive acute angle, what does acute mean? That's the 90. All right. What quadrant do we need to be in? 1. First one. Good. Because acute means less than 90, so we have to be in this quadrant, first quadrant. Now, using some SOHCAHTOA, cosine was adjacent over the hypotenuse. When you guys drew your picture, remember you always went from the central part of the triangle. So the adjacent here would be 5. Hypotenuse would be 13. Does anybody remember how to find the side? A squared plus b squared is c squared. Or, you know what the is? Close. 12. Who said 12? Yeah. 5, 12, 13, 12. Good. Now, if you didn't know, we could absolutely use Pythagorean theorem. That's fine. Now, if you wanted to get the sine, though, sine's opposite over hypotenuse. So, opposite over hypotenuse would be 12 over 13. And since you're in the A quadrant, it would be positive. Do you guys remember doing this, drawing your pictures a little bit? Figuring it out? All right. This is kind of where I see it come into play quite a bit. Now, the questions you guys can get. Do you have a question? Okay. Now, the questions you guys can get really range in how they're asked. So, one way you can see this is like a multiple choice, where they say, what is this equivalent to? Sine 22, cosine 18. Do we know anything about 22 degrees or 18 degrees? Yeah, oh yeah, good. We only know there are 2. We don't have an order of care for them. But whenever we see this kind of like pattern, sine, cosine, plus cosine, sine, you'll see a bunch of different ones, right? They're coming from your formulas. So what we want to do is figure out which one matches up to going sine, cosine, plus cosine, sine. Right? Watch out really careful because they look all very similar, right? Watch out the pluses and minuses too. So we want sine, then cosine. Ooh, plus though, cosine, then sine. It looks like the first one. Do you guys see how that matches up? Sine, cosine, plus cosine, and sine? Good. Now, in here, using our formula, this is the same thing as sine. Right up the whole thing. Sine of A plus B. That's what this really equals. Now, in our problem, what do you guys think is like the value of A? 22. Good. So A is 22. What's the B thing? 18. Great. So if I did sine of 22 plus 18, what would that give you guys? Sine of 40. Great. That's it. That's it. Yeah. It's more just like matching it up to a pattern.
They give these to you?
Yeah, they give all this stuff to you. The biggest thing is you just have to be really careful when you pick stuff because they don't look really like kind of tricky. All right, why don't you guys see if you could try the next one? See if you can figure out which one goes cosine, cosine, plus sine, sine. Match it up. We got to figure out the A and the B, and maybe see what it would equal. Why are you telling me? I know. Honestly, like, I'm gonna go like
Yeah, they should be this one is like the they should all be there. All right. Did you guys use? Bring it back. Did you guys use this last one? Yeah. Good. So cos of 70 minus 10 when you guys did your A and the B, so cos 60. Right. Just watch out. You guys are careful when you pick them. That's the hardest part. So that's one way you guys could see these sum and difference come up. The other way that I see quite a bit on multiple choice, and you guys could get this as like a part 2 or a part 3 question, depending on how tough it is something that looks like this. Right? Now, they give you guys a lot of information. Cos x is 12 over 13. Sine y is 4/5. Then sine x minus y equals what? Well, anytime you guys see this, right? Yeah, I gotta look at it. I don't even know what it is. But it is one of those forms, right, Andrew? What this shows you guys is you're taking the difference but using sign. And in here, we don't have like A's and B's. You guys have X's and Y's. So in here, we're looking for whatever the sine A minus B formula is. So let's try and figure it out here. Let's match that. You got it, Frida. Yep, we're going to use this one right here. And one thing I would do, because you guys aren't using A's and B's, you're using X's and Y's, is right when we do the substitution, which one is like the A? The X or the Y? The X, good. And the B is like the Y. So when you guys plug this in, I actually write it out. Sine X, then you guys said it was cosine Y. Just watch out when you copy these down. They are very tricky. There was a minus between cos x sine y. I think that's literally the toughest part, it's like writing it down. Okay, now what we want to do is figure out, like, fill in whatever information we know. Okay, so we're going to fill in the given info. Okay. So we know cos x is 12 over 13. So where I see my cosine x, I'm going to fill this in with 12 over 13. Now they also tell us about the sine of y is 4/5. So over here, sine y is 4/5. Yep, so you're going to be multiplied, you're right, because they're smushed together. Now this is where we have to do some work here. Do I know what the sine x or cosine of y is? No. All right, so think about what we did in the very beginning. If you guys needed other information, what did you have to draw? Right, draw your little chart in a triangle. Okay. Just be careful that we're dealing with two different triangles here, because we have one that's dealing with x and one that's dealing with y. So what I'm going to do is figure out, I'm going to draw an x triangle and a y triangle here. I'll deal with the x one first. Now, when we dealt with the x, we talked about the cosine. Cosine is the adjacent over the hypotenuse. So let's go ahead and label our x triangle with this. So we have a 12. Hypotenuse would be 13.
Would that one be 5?
Very nice. Good. 5, 12, 13 triangle. They usually give you guys ones like this where you don't have to do a squared plus b squared plus c squared. That makes it really long, right? Especially if it's multiple choice. Now, do I have enough information to figure out what the sine of x is? Yeah, what would it be? 5 over 12, because we're doing the opposite, opposite over hypotenuse, 5 over 13 should be, right? So 5 over 13 should be that one. Okay. Now, again, we don't know what the cosine of y is, but we do know something about the y, so we have to make a y triangle. Here's our little y triangle. All we know is that the sine is 4/5, and the sine was the opposite over the hypotenuse. So, good job. You got it. So this one's got to be 3. Perfect. Now I want the cosine. So what would the cosine be? 3 over 5. Good job. So, and make this adjacent over hypotenuse for the cosine. That's how we're getting that. Once you guys do all your substitutions, now it's just, you know, basic multiplication. And, you know, don't stress too much about doing this in your head. All right, you can use a calculator. Just make sure when you multiply, right, multiplication comes before addition or subtraction. So we have to multiply, then we're going to subtract. Yeah?
So, like, say, like, you messed up and you can get stuff like 5, 13, and 3, and it's stuff that doesn't matter, right?
Oh,
It just seems
no, I
weird
guess not.
because I thought we did, like, the cosine triangle, and then we put it like a sine, and...
Yeah, because it's like what you were given. Because, like, you know what you want to pay attention to? Because it's x.
Mm-hmm.
So these are coming, that's because it's like the x triangle. Same thing, like the y's are going off like the same triangle. Oh, no, that's like, whatever, I mean, they could put a and b in here, they could do x and y, h and k. Yeah, but they're just telling us that there's different equals that you have to use. Okay. All right, we'll see. This one's going to give you guys, you multiply top, bottom, use the calculator. 15 over 65, and then 48 over 65. Good.
That's a long multiplication.
Negative 33 over 65. Good job.
That was a long multiplication.
You guys will get some that are really long, and like all your multiple choice are not going to be like just easy like one steppers. You'll get some like that kind of thing. All right, let's check out this next one. Okay, so this is kind of nice. All right, so they give you tan A is 8, tan B is 1/2. What is the value of tan? Ooh, that A plus B. Right, as soon as you guys see things added together, it's not just going to be something you can just add. Right, it's coming from one of your formulas. Okay, this tan A plus B formula. So the first thing I should do is write everything out. Tan A plus tan B over 1 minus tan A tan B. Right. So once we have everything kind of substituted, right, let's see what we know. Do I know what tan A is? Yeah, it's 8. Good. So I know what tan B is. This one's nice. You have all your information. So if you don't need to do anything else, just substitute this one in and solve it. So tan A is 8 plus 1/2 over 1 minus 8 times 1/2. You've got to be really careful with kind of order of operations in here. Do you guys remember back in maybe middle school, 9th grade, when you had operations over like a fraction, it was like invisible parentheses, you got to do the top, do the bottom, and then divide. Okay, so kind of the same thing here. Okay, and if you're struggling, especially with the fraction work, it's multiple choice. I mean, there's nothing wrong with taking your calculator and actually doing, you know, 8 plus parentheses 1/2. And then using your little math fraction key, right, 17 over 2, that works. And on the bottom, what would you guys want to do first, multiplication or subtraction? Multiplication, good. Now, we could probably do this first in our head, but half of the 8 is just 4, and 1 minus 4, negative 3, yeah. All right, so we have 17 over 2. Divided by negative 3, we get negative 17 over 6. Hopefully that's the answer. How are you guys doing so far with this? Is it confusing to you? Not too bad. It's a lot of just subbing into formulas, and that's basically it. See if you guys can figure out which one we should use next. Hello? Hi. Yeah, right now? Okay, yes, guys. I'll show you guys all. These next two are very similar. I see these a lot on multiple choice.
cosine of 90 plus theta. Which one do you guys think you should be using? Good, nice, Rita. Good job. Cos A plus B. Alright, you just have a different value for what the A and the B are here. What do you guys think the A is like in this? 90. Good. What's the B? Theta. Good. Alright. So, again, just be careful. Write it down carefully. And instead of the A, I'm going to put a 90 in, so it's kind of like ready to roll in our formula. So, cos 90 cos theta minus sine 90 sine theta. Okay, so let's look at this. Do we know, and usually when you guys see things with like one variable and one degree measure, it's something from an ordered pair or something that you could easily do on a calculator. Do we remember with your 90 degree, here's your 90, here's your ordered pair, 0, 1. Yep, good. Cosine of 90, let's see, cos of F, right, is just 0. So if you're taking 0 times cos theta, what's this part going to be? 0, good. Alright. Now what about the sine of 90? 1. Yeah, 1. This is saying 1 times sine theta. Well, 1 times sine theta is just good. So 0 minus sine theta. Yep, negative sine theta. Right? Just again, plugging things in. Why don't you guys see if you could do the next one? Sorry, Al. See if you can try 6. Make sure you're taking the correct formula and stuff. You guys don't want to like flip back and forth to it on your stuff on the back of your cover page too. Your cover page on the page for the chapter, like your reference. You have my reference sheet over there. If you want to. You want to flip back and forth, it's fine.
Funny, so this was right. I did on my calculator here, and it comes.
No, it should be okay.
Yeah.
What did you guys get for your sine 180? 0. Good. And then cosine 180 was a -1. Okay. So this becomes 0. Here we have minus a negative sine x. What's this going to become? Positive. So 0 plus sine x is sine x. How do we do with that one? Good. Okay. Now the last problem I put on here is because probably 4 years ago I saw this come up on a Regents, and like it was a huge debate in like school because this is something that's not in your curriculum, but it made its way on the Regents exam. So I just want to show you guys one and kind of get you thinking of how you could do this. And I'll show you what they should have like put on for you, because this is something technically that you're not asked to do. Okay.
Did they keep the question?
Yeah, they kept the question because the Regents is stupid. Yeah, they gave like an extra 1 point curve, but it was worth 4 points, so like it was brutal. We had like 2 people get it right. I called Stillwater, they had nobody get it right. It was like it was bad. 2 people, it was not good. So all right. Well, if they say something about the word exact value, do you think you could just type this into a calculator? No, exact value usually has something coming up with like ordered pairs involved. Let me ask you guys, sine 75, do we have an ordered pair for that? Okay. Now I want you to think about 2 degree measures that you guys might know that would come up with 75.
45 and 30.
Oh, that's good. Do we agree with that? 45 and 30? Okay, good. Now, what would you do with that 45 and 30? You would have to add them. Good job. So really, this is like saying the sine of 45 plus 30.
On A and B.
Yeah, it's like A and B. Isn't that crazy? Now, what they could have, it doesn't matter the order. So if you're going to ask which are 30 and 45?
Could you do like sine of like 80 minus 5?
Except, do we know anything about 80 and 5?
No. Wait, do we know anything about 45 and 30?
Do you know order pairs for those?
Oh, okay.
Yeah, so that's why you want to use this, because you know something about them. You don't know anything about 80 and 5. But technically, I mean, it would work, but you wouldn't get an exact value. You'd have to use like a calculator for it. Okay. What they should have given you guys to make it a real question was this. They should have at least given you sine 45 plus 30 to show the exact value of sine 75. You're not supposed to have to come up with this on your own in this like class. So I just wanted to show you guys one of these, so at least maybe, I don't think they'd ever do it again just because it was such an issue, but you never know. All right. So we'd have to use your sine A plus B. This is sine A cos B. Okay, I'm going to do sine A cos B is like 30. I always mess up on them. Sine A plus cos 45 sine 30. Good job. Okay. So especially because of the exact value, you want to be really careful with these. Top, bottom. Oh, okay.
Interruption for a few quick announcements. The CIT Club will meet today after school in room 404. And attention juniors, anyone who has not handed in your little piece of fundraiser kit, you need to bring it to Ms. Hamilton by 2:30 today.
All right, let's do what do you guys know about sine 45? What about good? Radical 2 over 2. Cosine 30 is radical 3 over 2. 45 is radical 2 over 2 again. What about sine of 30? 1/2, right? Okay, when we multiply, you got to do top, bottom. What's this going to be when we multiply these radicals? Radical 6 over 4. Right. This is going to be radical 2 over 4. Now, can we add radical 6 and radical 2? Are those like radicals? You're right, Matt. You just leave it. Good. Radical 6 plus radical 2. Since you do have a common denominator, we just put it all over 4. Okay? You could get funky looking stuff like that, right? As long as these are different rad cans, you can't add them together.